We're asked to find the area of region R, first of all, in this question. So it's going to be the integral from x equals 0 to whatever this point is of the function y with respect to x. However, the function is written parametrically, or the curve is written parametrically rather. So instead of integrating with respect to y, sorry, with respect to x, we can actually change the x to dx by dt. This is using the chain rule. They're the same thing. So we've got y, we've got x. Okay, I'm going to need to work out dx by dt. That's just going to be 6 cos t. And then the only thing I now need are the limits. So this is going to be when y is equal to 0. So y is equal to 0 implies actually sine 2t is equal to 0. So inverse sine is 0 or pi. Therefore t is 0 or pi over 2. Okay, we had the domain here, but we just need to check that that is going to be a situation that t is pi over 2 is the final value. So now I can say, and I might just have to come down here for this, so area is going to be the integral from 0 to pi over 2 of 5 sine 2t multiplied by 6 cos t dt. And we're just trying to write it in this form now. Well, sine 2t is actually 2 sine t cos t. If you're not familiar with that, then here's our double angle formula. We can let b equal a. So sine 2a is sine a cos a plus cos a sine a. That is exactly what I just said a second ago. So it's going to become pi over 2, 0, and then I'll change it to 10 sine t cos t times 6 cos t. And you can see the result follows 60 sine t cos squared t. We're then asked in part 2 to actually get this area, show that it's 20. Oh, sorry, I forgot the integrating with respect to t bit at the end. Right, well, the best way to do this is actually inspection or reverse chain rule, however you want to call it, and see and notice, well, remember that when you differentiate cos to the power of n, for any n, you bring the n down, you reduce the power by 1, and then you times by the derivative of cos, which is actually minus sine t. So you get minus n cos. And the result of this is that if you ever integrate cos to the power of something times sine, we can work back and see that actually, well, the integral would just be minus 1 over n times cos to the nt. So I can do exactly that here. This is almost my trial function, cos to the 3t. I'm raising the power by 1. If I differentiate that back, I'm going to get minus 3 cos squared t sine t. So I just need to put a minus 20 in to make it all work. Okay, if you're struggling with this kind of idea, just practice. The only other option really is to do a substitution, u equals cos t. But to be honest, that's just as difficult to observe, I think, as practicing and learning reverse chain rule. So I'm going to stick with that one. Okay, similar applies with if you have sine to the power of something times cos. Let me, just give you a little question to do on that. So what if I had cos t sine to the 7t? What would that equal? Well, we'd raise the power by 1, because when we differentiate that back, we'd get 8 sine to the 7t cos t. So I just need to then divide by 8 and put a plus c in. So that's the sort of thing that you need to be able to do, or would be very useful to be able to do. Okay, finishing this off, we're nearly there. So now it's going to be minus 20 cos cubed pi over 2 minus 20 cos cubed 0. Actually, cos of pi over 2 is just 0, so I'm just going to get 20 times cos 0, which is just 1, 20 times 1 cubed, which gives me the area of 20 that it's talking about. Nicely done. There's one final part of this question. Here it is. So told that part of the curve is used to model the profile of a small dam, shown shaded in figure 4, this one here. X and Y are in meters, the vertical height is 4.2 as indicated, and there's a horizontal walkway of width mn along the dam, and we're asked to work out this width. Okay, let me just get my parametric equations again. So what I can do is sub in y equals 4.2, and that will allow me to find out m and n. Okay, that means that sine 2t is going to be 4.2 divided by 5, which gives me 0.84. So 2t is then inverse sine of 0.84. We're working in radians here. Doesn't actually, does it ever say? Oh yeah, it does. That was in the domain. So inverse sine 0.84 gives us, so I'm in degrees. Okay, kind of jumped at me there that didn't look quite right. So angle unit radians, of course, and then 0.9972. I think there's an 8 after actually. Or, looking at the sine graph, the other one is going to be pi minus that. Which gives 2.1443. Okay, or from your cast diagram, if you prefer this method, got one here and here, and this angle is the same as this angle, so you can see we need to do 180 or pi, in this case, minus the angle. Just need to divide through by 2. This gives 0.4986 or 1.0721, what I did earlier. Now those are my values of t, remember, so I now put them back into x. So x is then 2.8693. That's actually this value here, or 5.2692. That's that value there. Those are the two values of x that correspond with this this height of 4.2, and therefore the width mn is going to be the difference between that, which ends up being 2.3999. Just subtracted these two, which gives 2.40 meters to 3 significant figures.